Okay, so as I said earlier, we got to go through this review because I think we still need it. We will be having a test the Tuesday before Thanksgiving, so we will be through this chapter. I was thinking this was the fourth chapter, and that's why I sent the new book home with you. But we do have still one more chapter to cover. But if this 3 week online stuff goes any longer, we will need that book. So it's good just to have it home. So anyway, so linear relationships. This whole chapter is
Mrs.
on.
Reed, your audio is really laggy. I can barely hear you.
Oh, really? Okay. Thank you.
I can hear you.
Let's see if that makes a difference.
Rock on, man.
Okay. So the whole chapter is on linear relationships. Linear relationships have a constant rate of change. That was what we first started with looking at was there a constant rate of change? And if there was, it was called the slope. And the letter that represents the slope is m. And we were using the equation y minus y over x minus x. So the difference in the y's over the difference in the x. And then if we had a graph, we use the terms rise over run, where a rise can be either positive if it's going up or negative if it's going down. But the run is always to the right, and the run is always going to be positive. The line will have at least one intercept. So if we have a vertical line, we're going to have an x-intercept. If we have a horizontal line, we're going to have a y-intercept. But if we have a line that has a slope of some number other than 0 or infinity, the line will have two different intercepts, the x-intercept and the y-intercept. And we saw that we can find those intercepts by plugging 0 into the equation for a variable and solve for the other variable and then do the reverse process. We can also just look at our graph and see what the x and y intercepts are. So in this case, the y-intercept, because we're looking at the place where the graph crosses the y-axis, the y-intercept is at 2, and the x-intercept is where it crosses the x-axis, and that's -3. So from the graph, we're just doing it visually, where they actually cross. From the equation, we're plugging 0 in for the variable. So if I plug 0 into this one, that eliminates that terms, and I'm just left with 3y equals 6, and divide by 3, and I get y equals 2. If I plug 0 in for y, I end up getting -2x equals 6. And so when I divide by a -2, I get x equals -3. So this line is graphed over here. We see the intercepts, and we prove the intercepts by using the fact that we can plug 0 in there. Okay, now this is where we kind of left off. We were looking at this. We started getting a grasp of this, but there's two forms of a line that we can use: the slope-intercept form and the point-slope form for when we are creating an equation. The slope-intercept, you have to know the slope and the y-intercept in order to use that. So once we know the slope and the y-intercept, we replace the slope for m, and we replace the y-intercept for b. So if I'm given an equation that has a slope of 3/2 and a y-intercept of b, my equation becomes y equals 3/2 x minus 5. If they just say come up with the equation and they don't say to put it in a specific form, this is all you have to do. You just have to replace that m and that b. If you're given a point with a slope, or you're given a point or given 2 points on the line, you're going to have to use the point slope form. And what we do with this form is we replace the slope with m, and we replace this y and this x. So the second y and the second x get replaced along with the slope. If you're given 1 point and the slope, like in this case, we're going to take the y coordinate. Remember, this is the y and this is the x. Y minus 2 equals our slope, 3 times x minus a minus 1. The only thing we would have to do with this is simplify that minus a minus 1. So y minus 2 equals 3 times x plus 1. So if we have the slope and a point, we plug those 3 in. If we're given 2 points, the first thing we have to do is come up with the slope by using our slope formula. So -1 minus 4 over 2 minus a minus 5. -1 minus 4 is a -5. Positive 2 plus 5, because of the 2 negatives, is 7. So now we get to pick either one of those points. It doesn't matter which one. I'm going to pick the first one. Y minus a minus 1 equals -5/7 times x minus 2. And we get y plus 1 equals -5/7 times x minus 2. Now, they also want you to graph the lines and from the given conditions that you were given. So the first one was a y-intercept of -5. So on my graph, I'm going to go down -5, -1, 2, 3, 4, 5. Here's my y-intercept at -5. And then from there, I use my slope of 3/2. From there, I rise up 3 units, 1, 2, 3, and run over. So I'm always going from the point that I just put down and using my slope from that point. And then I can draw my line. The second case, they gave us a slope of 3 and a point of -1, 2. So we graph that point. -1, 2 is right there. And then we use our slope from there. Up 3 over 1. And we get our second point and we draw our line. I don't know why I went off my drawing tool. And there's our line. Notice I'm not drawing my line very good, huh? And then the second one, they gave us 2 points. So all we have to do is plot those 2 points. And those 2 points were 2, -1, and -5, 4. 2, -1 is down here. And -5, 4 is right there. So creating the line and graphing the line are two of the things that they wanted us to do in section 3.5 and 3.6, using the slope intercept and the point slope. I'm going to stop the recording.